what if AI systems could not only think, but also, act and collaborate seamlessly, like working together like a perfectly synchronized team? Imagine an AI that doesn't just answer your questions, but proactively does things for you, and maybe even calls upon other AIs to help solve really complex problems.
Yeah.
Today, we're taking a deep dive into two key developments that are, well, starting to make this future a reality: AI agents and the Model Context Protocol, or MCP.
Right.
And we're also going to touch on a newer but really crucial player called A2A. So this deep dive will unpack what each of these are, how they differ, and most importantly, how they actually work together.
Yeah, how they fit.
To make AI genuinely useful in the real world, especially for businesses.
And our mission for you today really is to cut through all the buzzwords, all the hype around these concepts. We want to give you a clear, structured understanding.
Like a shortcut.
Exactly, a shortcut to being well-informed. Hopefully, you'll walk away with some real aha moments about how these technologies are, well, fundamentally shaping the future of AI.
Okay, let's get stuck into it then. When we talk about an AI agent, what exactly are we picturing? Because, for a lot of us, AI still feels like a chatbot, right? Something that just responds.
Yeah, and that's a great distinction to make right at the start. So an AI agent, at its core, is an autonomous system.
Autonomous, okay.
Which means it's capable of perceiving its environment, making decisions, and then actually performing actions to achieve specific goals it's been given.
Right.
And crucially, unlike that simple chatbot, which just spits back info, an AI agent can autonomously plan, decide, and act towards a goal.
Okay.
It uses advanced AI, often large language models, the tech we hear so much about, but also tools and memory. And it does this without needing constant human handholding. Think of it maybe like a virtual teammate.
A virtual teammate. I like that. So it's not just sitting there passively waiting for the next instruction. It's actively figuring things out and doing them. That feels like a really fundamental shift.
It absolutely is.
Less like a static tool, more like, an independent entity almost.
Well, yeah, in a functional sense.
So what kind of underlying capabilities or maybe characteristics allow an AI to actually do that, to have that level of independence?
Right. You've nailed the key difference. There are basically 4 essential characteristics that give it this power.
Yeah.
First is autonomy itself. You give it a high-level goal, and it just operates independently. No need for step-by-step instructions.
Okay.
It can handle, say, complex scheduling or data analysis all by itself. Second, memory. This is huge. AI agents store past interactions, things they've learned.
Right.
So they can recall context, learn from experience, and get better, more relevant over time.
So they actually improve?
They can, yes. Third, decision-making and planning. They don't just take the goal literally. They can break it down into smaller subtasks, plan out a workflow, make decisions along the way, and even, change course if plan A isn't working. It's dynamic.
Like real thinking.
Sort of, yeah. A form of it. And finally, tool use and environmental interaction. This is massive. An AI agent can actually interact with external things, tools, or the environment, as the source material puts it.
Like what kind of things?
Databases, APIs, files, the internet, even physical devices in some cases. It can use these to get information or to perform actions. So it's not just stuck inside the computer. It can affect the outside world.
Wow. Okay, that's fascinating. So this isn't just theoretical stuff then. Where are we actually seeing these AI agents in action today? Give us some real-world examples.
Oh, absolutely. Think about some advanced customer service systems, the ones that can handle really complex queries end-to-end without needing a human to jump in.
Okay.
Or autonomous vehicles, obviously. Navigating traffic, making split-second decisions based on sensors. That's agent behavior.
Right. Makes sense.
Even some smart home systems, the ones that don't just obey your commands, but actually learn your habits and proactively adjust the heating or lights. That's an agent learning and acting.
Got it. Okay, so agents are these powerful, autonomous doers, but, a doer needs tools, right? How do they actually connect to all the information and the tools they need to do these things? Because it feels like for years we've just been building custom one-off integrations, like fitting square pegs into round holes.
You've just described a major pain point in the industry. It's often called the MEM-N integration problem.
M by N.
Yeah, M times N. Imagine you have M, different AI models you want to use, and N, different data sources or tools they need to connect to.
Right.
Historically, that could mean building and maintaining M times N separate custom integrations. It's a nightmare to scale.
Yeah.
It just doesn't work in the long run.
Okay, I can see how that gets messy fast.
Exactly. And that's precisely where something called the Model Context Protocol, or MCP, comes in. Its superpower, really, is standardization.
Standardization. So it's
Yeah.
like a universal translator or maybe an adapter for AI. I heard a really neat analogy for this. MCP is like the USB-C of AI
That's a
applications.
great one, yeah.
Just like USB-C gives you that universal plug for all sorts of devices, MCP offers a standard way for AI models to connect with different tools and data sources.
Precisely. Or another one people use is like a standardized telephone line for AI. Everyone agrees on how the call connects.
Okay, the USB-C one really clicks for me. That explains the what. But how does it actually work? Can you simplify the mechanics a bit?
Sure. So in simple terms, let's say an AI application, we can call it the host or the MCP client, needs something done, like search for customer XYZ in our company database.
Right.
It sends that request using its MCP client software. But here's the key. The request doesn't go straight to the database itself.
Okay, where does it go?
It goes to something called an MCP server. This is usually a lightweight program that sits sort of in front of that specific tool or database or data source.
Like a gatekeeper.
Kind of, yeah, or maybe a translator. The server takes that generic MCP request, translates it into the specific command or query that that particular database understands, executes it, gets the result, and then sends it back to the AI agent in a standard MCP format.
Ah, okay. So the agent doesn't need to know the specific language of every single database or tool out there.
Exactly. It just needs to speak MCP. The server handles the specifics for each tool. This hugely simplifies development. Imagine building an agent, you just teach it MCP, and suddenly it can talk to potentially hundreds of different tools via their MCP
That
servers.
sounds way more scalable.
Massively. And it enables secure two-way connections in a consistent way. Great for complex enterprise environments.
And this isn't just theory, right? I read that even major players like Anthropic are already using MCP, like in their Claude desktop application.
That's right. It's a perfect example.
They use MCP to let the Claude agent access and summarize files on your local computer, right? But crucially, without sending your private files up to the cloud.
Exactly. The MCP server runs locally, mediating access to the local file system. The agent sends an MCP request, the local server gets the file content, summarizes it or whatever the task is, and sends the result back via MCP. The sensitive data stays put.
That's huge for businesses, especially in regulated industries, or for governments worried about data sovereignty. Privacy and control are paramount there.
Absolutely critical.
Okay, so we've got the autonomous doers, the AI agents, and now we have MCP, the universal connector, letting them talk to tools and data. But what happens when one AI agent needs to talk to another AI agent? That feels like the next frontier.
It really is.
Does that introduce a whole new level of complexity and maybe capability? Is that where this new thing, A2A, comes in?
Precisely. You're thinking exactly along the right lines. That's where true AI collaboration starts to happen. A2A, which stands for Agent-to-Agent Protocol, is a relatively new standard. It was introduced by Google, I think, in April 2025, but already has backing from over 50 tech partners.
Wow, 50 partners already, so there's momentum.
Definitely. And it's designed specifically for this purpose, allowing agents to communicate effectively with each other within multi-agent systems to solve problems together. It basically standardizes how agents can discover, delegate, and coordinate tasks across different domains.
Discover, delegate, and coordinate. Okay, so it's not just about talking to tools anymore via MCP. It's about enabling communication between different AI brains, essentially.
That's a good way to put it.
That feels like a massive leap. How does A2A actually make that happen, that kind of sophisticated chat between agents? I heard it described as sort of combining, like DNS for finding things, messaging protocols for talking, and maybe digital identity services. Is that close?
That's a really insightful analogy, actually. It captures the core functions well. A2A has several key components that enable this. First, you have agent cards.
Agent cards, like business cards for AIs?
Kind of, yeah. More like a resume, maybe.
Right, yeah.
It's a public declaration from an agent saying, here's who I am, here's what I can do, and here's how you can talk to me. It lists its identity, capabilities, and communication endpoints.
So other agents can find it and know what it's good at.
Exactly. It enables discovery. And you can imagine this leading to like a dynamic AI marketplace where agents could find and hire other specialized agents for specific tasks, like a job board for AI services.
Yep, cool. Hyper-specialization.
Potentially, yes.
Yeah.
Then there are tasks. These are structured requests sent from one agent to another. They clearly define the intent, what needs doing, the inputs required, and the expected outputs.
A formal request.
Very structured, yes. Then you have messages and parts, which are basically the encapsulated communications linked to these tasks. Think status updates, intermediate results flying back and forth, or the final response.
Okay.
There's also a defined lifecycle for tasks. They go through stages. Created, then hopefully accepted, then in progress, and finally ending up as completed or maybe failed or canceled. It tracks the whole interaction.
So you know what's happening.
Right. And the communication model itself uses JSON RPC over HTTP, often with server-sent events, SSE.
Okay, technical details, but what does that mean practically?
Practically, it means fast, efficient data exchange. And crucially, the SSE part supports message-level streaming.
Streaming, like video streaming.
Sort of. It means for long, complex tasks, an agent doesn't have to wait until the very end to get an answer. It can receive continuous updates, intermediate results, progress reports as they happen.
Ah, like getting live updates on a project instead of just the final report.
Exactly like that. Much more interactive and efficient for complex workflows.
Okay, that sounds incredibly powerful, but why is this so important? What's the real game changer about agents being able to talk to each other in this structured way?
The massive advantage is that it allows agents from different vendors or operating in totally different domains, say finance and logistics, to coordinate as peers.
Without needing custom integrations between them.
Precisely. Agent A can delegate a subtask to Agent B, track its status via the A2A lifecycle messages, and then seamlessly incorporate the results Agent B sends back. All without needing deep, bespoke integration or Agent A needing to know the specific internal workings of Agent B.
That sounds foundational.
It really is. It's foundational for building truly modular, flexible, multi-agent systems. You can have agents forming teams, maybe even hierarchies dynamically on the fly to tackle much bigger, more complex problems than any single agent could handle alone.
Right. It shifts us from thinking about isolated AI tools to like a collaborative AI ecosystem.
Exactly, an ecosystem.
Okay, so now it feels like we have three distinct but clearly related pieces on the board. We've got the intelligent actor, the AI agent itself. We've got MCP, the universal connector for its tools and data.
Right.
And now A2A, the communicator, letting agents talk to each other. What's really fascinating here is how they all play together. It feels like they're not competing, but are they like building blocks for something much bigger?
They are absolutely complementary, not competing technologies at all. And there's a fantastic analogy from the source material that sums this up perfectly.
Oh, yeah. Let's hear it.
Think of it like this. AI agents versus MCP isn't a fight. It's more like comparing the pilot of an airplane to the navigation system.
Okay, I follow. The pilot is the agent making decisions.
Exactly. The agent, the pilot, flies the plane, makes the decisions, reacts to the conditions. MCP, that's the navigation system. It provides the maps, the connection to external data, the communication channels to ground control, which represents its tools and data sources.
Got it. Pilot uses the nav system, agent uses MCP.
Right. And then if we zoom out to the bigger picture, A2A is like the air traffic control system.
Ah, okay.
A2A allows different pilots in different planes, that is, different agents, to coordinate their flights with each other, talking plane to plane, ensuring safe and efficient travel in the shared airspace.
That analogy really ties it together nicely. Pilot, nav system, air traffic control, agent, MCP, A2A. So, and just to check my understanding, an AI agent provides the brains and the autonomy, the ability to act.
Right.
MCP provides the connectivity of the sort of data plumbing to let it use tools and access information.
The tool integration layer.
And A2A provides the framework for collaboration and coordination between different agents.
You've got it exactly right. That paints a very clear picture of the whole ecosystem.
Yeah.
MCP handles what we might call vertical integration, the agent reaching down to invoke tools or pull data.
Okay.
A2A enables horizontal communication agents talking across to each other, peer-to-peer.
Vertical and horizontal. Got it.
And this clear separation allows for a really elegant modular design. Each agent can essentially act as a dual participant. It can be an MCP client calling out to use tools,
Right.
and simultaneously it can be an A2A endpoint, exposing its own capabilities to other agents and ready to receive tasks from them.
Okay, that makes sense. Can we walk through maybe a quick real-world flow to see how they actually interleave, like that travel assistant idea?
Yeah, absolutely.
Yeah.
The travel assistant is a great example. Let's trace it. First, a travel assistant agent gets a request from a user, maybe through a chat window. Book me a trip to London next week, business class, stay near the convention center. It takes this complex request and breaks it down into subtasks. Find flights, book hotel, maybe arrange airport transport.
Okay, standard agent planning.
Right, 2.
Yeah.
Now, instead of trying to do everything itself, it sends a structured A2A task, maybe find and book flight, to a separate specialized booking agent. This is the horizontal communication, agent-to-agent delegation.
Got it. Passing the buck efficiently.
Ah, yes, efficient delegation. 3. Okay, now, the booking agent receives this A2A task. It then uses MCP, the vertical integration, to interact with external systems. It calls airline APIs via an MCP server, queries hotel reservation systems through another MCP server, maybe even uses a corporate payment gateway tool via a third MCP server.
So the booking agent uses MCP for the actual doing.
Exactly. It uses MCP to connect to and operate the necessary tools. 4. Once the flights are found, the hotel is booked. Payments are processed, all confirmed via MCP responses. The booking agent packages up the results and responds with a completed A2A task back to the original travel assistant agent.
And the travel assistant tells me, the user.
Right. The key takeaway is the coordination between the different agents, that's handled by A2A. But the execution inside each agent, the part where they use external tools and data, that's driven by MCP.
That flow makes it crystal clear how they work hand in glove.
Okay, this raises a big question then. What does this all really mean for us? Beyond the cool analogies and the tech specs, how are these protocols actually transforming real-world applications? What's the bigger picture here? Because it really does sound like a fundamental shift in how we build and use AI.
It is a fundamental shift, and these architectures are genuinely transforming how entire departments can function within businesses, for example.
Like how?
Well, consider an HR agent that kicks off an employee onboarding task. Instead of one monolithic system trying to do everything, the HR agent might delegate via A2A the background verification part to a specialized security agent.
Okay.
That security agent then uses MCP to securely query, say, external background check services or maybe internal security databases.
Right, using the tool connector.
Exactly. Now, if an issue is flagged during that check, the security agent might automatically trigger another A2A task, this time to a dedicated legal agent.
Ah, bringing in another specialist. Precisely. And that legal agent could then use MCP to connect to internal policy documents or perhaps case management tools to review the flagged issue. And crucially, each step in this chain, HR to security, security to legal, is transparently auditable through the A2A task logs. Everything is task scoped and role governed.
That sounds much more organized and secure.
It is. And it supports this idea of ephemeral agents.
Ephemeral, like temporary.
Yeah, micro agents that can be spun up just for a specific task, like that background check, and then dissolve once it's done. It's incredibly efficient. Think of it like dynamic resource allocation, hiring a specialist contractor for just one precise job.
Okay, I see the power in enterprise settings. What about beyond just office workflows? You mentioned environmental interaction earlier.
Yes, absolutely. This isn't just about text and databases. These protocols are designed from the ground up to be multimodal and to handle interactions with the physical world, like in robotics.
Okay, give me an example there.
Sure. Imagine an industrial robotic maintenance agent on a factory floor. It might detect an anomaly using its visual inspection capabilities, say, a crack in a component.
Okay.
It could immediately use A2A to send a structured task notification. Part XYZ requires replacement at location ABC to a supplier agent managing inventory.
Right. Ordering the part automatically?
Potentially, yes,
Yeah.
or at least checking stock. Simultaneously, that same robotic agent might use MCP to trigger a voice assistant to update a nearby human technician in real time about the issue.
Hands-free update. Nice.
Yeah, and it might also use MCP to initiate specific actuator routines to safely prepare the area for the part removal. And throughout this, all the involved agents, the robot, the supplier agent, maybe a central monitoring agent, could be streaming status updates via A2A using that server-sent events capability we mentioned.
So the technician gets continuous hands-free reports on their headset while they walk over.
Exactly. It shows how A2A and MCP can integrate vision, action, voice, and interagent coordination seamlessly.
That's impressive. It really does sound like this goes way beyond just making AI smarter. It seems to make it more manageable, more audible, more controllable. But that brings up some broader implications, right? Especially around trust and maybe sovereignty in a world increasingly run by these interconnected AI systems. Because when you start connecting all these powerful, autonomous pieces, especially if they're from different companies or cross borders, does that introduce new layers of complexity, maybe even new security risks that we need to be thinking about?
You've hit on absolutely critical points there. And the designers of these protocols are thinking about them too. First, on the flexibility side, using open protocols like MTP and A2A drastically reduces what engineers call integration debt.
Meaning less time spent making things talk to each other.
Exactly. And it allows for more plug-and-play AI systems. Organizations can adopt a new, better AI model or a new tool without having to rewrite huge chunks of their existing systems. This helps avoid vendor lock-in, which is a big concern for many companies.
Okay, that's a practical benefit. What about the trust and control?
Well, a key aspect here is that control is moving down to the protocol level, not just relying on the application logic built on top.
What does that mean, protocol level?
It means the rules of engagement are baked into the communication standards themselves. With MCP, for example, tool access is secure and scoped. A tool can only be used via its predefined MCP server schema, limiting what an agent can ask it to do. And all those MCP interactions are designed to be audit loggable.
So you have a record.
A detailed record. And with A2A, it enforces trust-based delegation. Remember the agent cards. They establish identity and verified capabilities. Tasks have that traceable lifecycle. And you can set permissions granularly, controlling which agents can talk to with other agents, perhaps based on their domain or even their geographic jurisdiction. It's leaning into zero trust by design principles for AI interactions.
Zero trust. Verify everything.
Essentially, yes. Don't assume trust. Enforce it through the protocol.
And how does this relate to sovereignty? That's a big topic for governments and regulated industries.
Hugely important. For them, these protocols offer a path to deploy powerful AI capabilities without necessarily surrendering control over data flow and decision-making. Sovereignty, in this context, isn't just about where your AI models are physically hosted.
Right. It's more than just servers.
It's about how agents collaborate, how they access sensitive data, and how decisions are delegated and executed. A2A and MCP allow for implementing local control. Interactions can be kept transparent, and you can enforce jurisdictional boundaries. Maybe an agent in one country isn't allowed to delegate certain tasks to an agent hosted in another.
So the protocols themselves help enforce those rules.
That's the goal. However, you raised a crucial point about complexity and risk, and we absolutely have to acknowledge that.
Yeah.
While incredibly powerful, these highly interconnected multi-agent systems do introduce new challenges. Debugging can become more complex when a single user request involves multiple agents potentially running on different servers, maybe even owned by different organizations.
Tracing a problem could be tricky.
It could. And there are valid concerns about potential new attack vectors. If agents can discover and talk to each other, could malicious agents try to infiltrate the system or trick legitimate agents? Data privacy also needs careful management when information is flowing between multiple nodes.
So it's powerful, but not without things to watch out for.
Definitely. These are very real areas that require ongoing research, development of best practices, and careful architectural design as these systems become more widespread. It's not magic, it's engineering, and it requires diligence.
Okay, so let's try and bring this all together then. We've journeyed through the world of AI agents, the autonomous doers. We've looked at the two powerful protocols enabling them. MCP, acting as that universal connector for tools and data, and A2A, providing the communication backbone for agents to actually collaborate effectively. It seems really clear they're not fighting each other, but performing this synergistic dance that creates something much more robust and scalable than either could alone.
That's perfectly put. And what's truly fascinating here, I think, is that this combination, what some are starting to call the agent interoperability stack, A2A and MCP working together, is fundamentally defining how sophisticated AI systems should be built for the future.
The blueprint, almost.
Kind of, yeah.
Yeah.
It represents a move away from isolated, monolithic AI bots towards systems that are modular, that are auditable by design, and that allow for genuine sovereignty and control. This translates into AI solutions that aren't just smart in isolation, but are deeply integrated, highly adaptable, truly collaborative, and ultimately deliver far more tangible value and control in complex real-world scenarios.
Okay, so here's where it gets really interesting for me, thinking about the future. If you look back, the internet itself was built on open standards, right? Things like TCP/IP for basic connection, HTTP for the web, and those open standards allowed for this unbelievable explosion of innovation on top.
Absolutely. A Cambrian explosion of creativity.
So the provocative thought I want to leave our listeners with is this. What transformative possibilities might open up when our AI systems, from our personal assistants, maybe all the way up to national infrastructures, are built on similar open interoperable protocols like A2A and MCP? How might a future where AI truly speaks a common language, able to discover, delegate, and collaborate reliably, fundamentally reshape not just how we automate tasks, but how we interact with technology, and maybe even how we structure and govern our increasingly digital and interconnected world?